Okay, so today we'll be talking about the minimum window substring problem on Leetcode. Given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. This is not as important. So looking at this is the shortest substring. You can find one like this as well. And you can also find one like this as well. That was obviously going right to left, but we'll be doing it left to right in the code. If it's the same string, obviously you just return the same string. If this string is longer than this, then it's impossible just due to the nature of how that works. And so we'll be coding the edge cases. If length of s is equal to 0 or s is none or t is none, then we want to return this, because if this string is empty, we can't find anything here. Even if both of them are empty, I don't think it's possible. I mean, even in that case, you would still return this anyways. If this is none or this is none, then it's impossible to find a substring of either of those. So you just return none. So if length of s is less than length of t, then you also return this. You could code this as part of this if statement. However, I think this just makes it a bit more readable in the sense that like you have passed the base cases. However, this is an edge case where, like it mentions here, if s is shorter than t, it's impossible. Right, so we'll also return an empty string there. And so now we're going to initialize variables. So we're gonna have left is equal to 0, count is equal to, I'll explain all of these after typing them all, because I figured that like every time I end up doing typing one of the comments, eventually I have to shimmy it over because the stuff at the end just gets longer and longer. And so yeah, so left is the left bound of our sliding window. This is dictionary to hold the character and the count in string t. The amount of characters we have found in S that are in T with the same count. So I think this will become a bit more clear as we move on, but it's basically, for this case, once we find 1A, we will increase the match. Once we find 1B, we'll increase the match. If we find 1C, we'll also increase the match. And for a case like this, let's just ignore S for now. But for this, we will only increase the match if we find 2 A's in our window. So if that helps you understand the match variable. Min window left is not to be confused with left. Left is what will be moving throughout the problem in order to determine our windows. This is just the shortest. This will only be set whenever we find the shortest window. So if we never find the shortest window, this variable will never be set. But this is just the left bound of our results window. And so this is the length of the shortest substring that answers the problem. And we started off at infinity because since we're going to a shorter and shorter length, we need to start at infinity and work our way down. So here we're going to get the car and count, because we need to, see how many of each character is in our string t. So we want for car in t, for count of car is equal to count.get car 0 plus 1. Basically we just get the value of this, or default to 0 plus 1, and set that equal to that. Right, and so here we're going to do for every character see if it matches, and if we hit the match count, we will shrink and calculate the shortest window that still satisfies the solution, the problem statement. So if we're right in the range of length of S, we will see if first S right is in count. If it's not, we don't care about it. If it is, great. We're going to decrement the count. Minus equals 1, and if count S right is equal to 0, we will match plus equals 1. Yeah, so basically once we hit the match limit, or not the limit, but we have hit the match count as checked by this condition, we will want to calculate to see if right minus left plus 1 is now less than shortest. Since the solution will be unique, we can just do less than. If we can also do equal than, and if they want a window of every substring that's possible, then yeah, that's what we would want to do. And so here we will do this. I guess I'll explain the plus 1 for people that don't know. So in this window, since we're going left to right, this is the first window in which we satisfy the problem statement. And since it's index 0 to index 5, because it's 0-based indexing, and then 0, 1, 2, 3, 4, 5, 5 minus 0 is only 5. However, there are 6 characters here, so that's how I remember that I have to add 1 to calculate the length of the string. And so min window left is equal to left, because at the current left bound we have satisfied our problem statement, and so we want to set this. And because we know that it's shorter, the current length of our window is shorter than whatever value we have shortest at, we can just set our min window left, which is our result left bound of our result window. We can set the left bound there, and we will set our shortest equal to right minus left plus 1, just so we can keep that for later when we need to return our solution. And so now if S left in count, so now we're trying to shrink the window, right? Here, I'll type that out actually. Shrink window. So now we're trying to shrink the window. So if the current left bound is in count, then we want to, if count of S left is now equal to 0, then we want to decrement our match counter. We want to increment whatever's at the left, and regardless if we increment the left bound or if we change anything in the count dictionary or not, we still want to increase the left boundary here, and it'll go back through this while loop. If this holds true, after going through one loop, this will definitely be shorter, just because left has increased by 1. So now we're subtracting by a number that's 1 greater, and so it will definitely be shorter if this statement holds true though. If not, then obviously we'll move on to the next iteration of the for loop, because we are done with the solution, aside from the part that we have to return though. So we want to return an empty string if shortest is equal to float infinite, because this just means we never found a shortest window, which also just means like we never found a substring in which we satisfy the problem statement, right? So we want to return this if it's if our shortest is still equal to infinite. Otherwise, we want to return S, and so you can index strings this way in Python. So min window left, and we're going to min window left plus shortest, and that should give us an answer. I was playing around earlier, and so that's why there's so many. but this hopefully works. Runtime error. Oh, okay. Well, just forgot the +1, I suppose. Maybe deleted that earlier. But yeah. So there you go. It works.